All right. This video we are going to talk about radicals, square root, and cubic root and all this. So, see, if we talked about if we put this one in the computer, in the calculator, what is going to be? You turn this on, clear, it say radical, a square root, you put second, and here to the x squared, the one that you see is radical, and number alphabet I. If you put second, this one is going to show the a square root of what we are trying to say is a square root of 2, 31.4142, and you know this is irrational number. Every time we repeat it, the decimal number is repeated, and every time it's a different number. These are irrational number. So we want to know what is the square root of. We know that the square root of 4 is 2. Means it's 2. 4 is 2 multiplied by 2. 4, 2 times 2. Okay. So we can write it 4 as 2 to the power of 2. The reason that we find that this is a square root is we cancel out. We write this one to the exponent form, 2 to the power of 2. 2 and this 2 cancel out, and the result is going to be 2. The square root of 4 is going to be 2. The square root of 8. We can write it this way. As we said, one of the properties, and we can break it down like this. A square root of 4 times the square root of 2 is going to be a square root of 8. And then, but a square root of 4 is going to be 2. And we talk about it. 2 times the square root of 2. 2 times 141 is called 2.82, you know, in 2 decimal places. We write this one as the 2 decimal places. It depends what they ask you. So if we have 16, how do we find the square root? We say 16, you don't break it down. 16 is what? Divided by 2, we can divide this one because it's an odd, even number at the end. 8 divided by 2, 4 divided by 2, 2 divided by 2, means 16 is equal to 2 to the power of 4. Means 4 times you multiply 2 4 times and you will get 16. So we can write it is the power of 2 to the power of 4. Okay, we can write this one. No, not clear. We can write this one, you know, is a square root of 2 to the power of 2, which is cancel out is 2. And you see that this one, if you write it like this, 2 to the power of 2 times 2 to the power of 2, this one cancels out with this, is going to come out of the radical, is going to be 2. And this one, again, you know, you could write this one to the power of 2 to the power of 2. This is going to cancel out, it's going to be 2, and then times multiplied by 2, because this cancel out, it's 2. So it's going to be 4. 4 is going to be the square root of 16. Means if you raise it to the power of 2, you are going to get 16. Okay. See, you got to realize that if we say 5, the square root of 2, it's different from, this is multiplication. When it's a multiplication, we don't write it. We say 5 times the square root of 2. Is actually 5 multiplied by the square root of 2. And what is there going to be the result? 5 times 1.41, whatever it is. And I think 7.05. It's going to be 5 times 1, 5, 5, 4, 2, 5 times 1 plus 2 is good, yeah. It's, but if this one is 5 plus the square root of 2, this is has a different meaning, the different result. It means 5 plus 1.41 is equal to 6.41. So, you write that this is multiplication. When we don't write, anything behind it, like in other, we have a polynomial like 5x. It means 5 times x. Different from 5 plus x. This is different. Like if x is, for example, x is an unknown number, and this unknown number, if x is equal to 1, substitution we do. If x is equal to 1, then 5 times 1 is going to be 5. But here, if x was 2, 5 times 2 is going to be 10. But here, if it's x2, we say 5 plus 2 is going to be 7. So you just want to realize that if we don't have the we could write 5 times x, okay? But usually in algebra, in mathematics, they don't write this. They say 5x. Okay. How about the cubic root? This is index was 2. The index now is 3. If you have something like 8, you see, 9, I'm sorry, 9. See, if it was a square root, suppose that it was a square root, okay? And the square root of 9 is going to be 3. But if this one is 3, 9, we cannot do anything with it, I mean, talking about write it as integer, as a number, but we can write it this way, 9. We always can write this way. This is the exponent of 9. Here, if there is nothing, is 1. It means it's 1. So we can write this one as 2, as like this, And if like we have 6 power 4, how did you write it? We can write this radical as 6 to the power of 4 over 3. The 4 exponent of this one, we write it first, and then we write the index of the radical, which is cubic root of this number. So we can write like this. But how about if we have a square root of 3, the number is 27. See, 27 is 3 to the power of 3. This cancels out. So a square root of cubic root of 27, I said 27, not to the power, see, not to the power of 7, I was writing here, this means power. 27, the square root of this is going to be 3. How about if this one is 54. What you do, you break it down. 54, you say divided, we cannot divide, we can divide also this one by 3, because 5 plus 4 is going to be 9, it's going to be divisible by 3. We can also divide it by 2. But you divide it by 2, it's going to be 27. Then we have to divide this one by 3, because we cannot divide this one by 2. So divided by 3 is going to be 9 divided by 3. 9 divided by 3 is going to be 3. 3 divided by 3 is going to be 1. So we can write 54 as 3 to the power of 3 times 2. So we can write it like this. This is 3 to the power of 3 is going to 27 times 2. So we can write this way, that we can write 27 times square root of 3. You know, remember that one of the properties of the radicals, that we can write this. The 2 times 27 is going to be 54. So 27, it is 3 to the power of 3 and plus 2 cubic root of 2, this way. See, this is the same as this, and we say that this cancels out 3 in multiplication. This is multiplication. This is multiplication. Multiplication, I show it like this. So 3 is going to be times 3 square cubic root of 2. So actually is 3. The answer is going to be like that, you know, simplified like this. So how about the addition and multiplication of these? You know, say like we have, we talk about the square root. The square root of 2 plus the square root of 5. What is going to be? This is 1. This is actually plus 1. So it's going to be 6. I'm sorry. 1 plus 1. What am I doing? I was going to say right like this. 1 square root of 2 plus 5 square root of 2. You know, this you add these together. It's going to be 6 of them. This is like 6 square root of 2. See, if you have square root of 3 plus square root of 2 minus 4 square root of 2. You know, you cannot add this, because this is like, this is talk about a fruit. This is like apple, and this is banana. You can add these together. We say, hey, we have this much banana. You add this banana together. You add this. The result is going to be, because it's going to be 4 square root of 2, 1 square root of 2 minus 3 square root of 2. But you can find the value, you know, you can find the value of this one is $1.73. Square root of 3, 1.732, and then so on and so on. So you can find, say, up to 2 decimal places in 1.73 minus 3 times 1.41. See, these are the quantity. These are the numbers. Actually, you can add this way, but you can't say, hey, we have 4 square root up to 1 square root up to minus 3 square root, and there is 1 here. We can't say, you know, add these numbers together. We say minus 3 plus 1. It's going to be minus 3 again, because, you know, some of them are in a square root. And this one is a square root of 3. This is a square root of 2, and this is. So you add these together, you can say. But so let's talk about. So this one has to be, if we add this together, you know, we write minus 5 square root of 2. You can add all these because they are all, these are all apple, for example. So it's apple. This is a square root of 3 is like banana or something else, you know. A square root of 5 is pineapple, for example. We cannot add all this together, all the pineapple together, all the apples together, you know, all this. So this is going to be minus 9 square root of 2 here. And this is plus 1. This is 1 square root. Plus the square root of 2. And this is going to be minus 8 square root of 2. Minus 8. Okay, how about multiplication? We write multiplication. This is multiplication now. This times. This is going to be. When we multiply these together, this we can write 2 times 2. We could say 2 times 2, and then we can say like this. It's the square root of 4, which is 2 now. You mean, you know, we talked about it. 2 to the power of 2. These to cancel out, and the result is going to be 2. How about 5 square root of 3? Times 3 square root of 3. See, these are a square root of 3. Okay. Now we can multiply together. Or suppose this one is 2. You make it a little complicated. This is possible too. See, we multiply the coefficient together. 5 times 3 is going to be 15, and then we could say like this. We could write it like this: 15 square root of 6, because the index are the same. Both are a square root. We can write it like this. Okay. We talk about see, talk about division now. A square root of 27 divided by the square root of 8, for example. You just write it 27 over 8. You can write it this way. But this one is, if it was 9, what's going to happen? We write it like this: 27 divided by 9 is 3. So this is going to be the answer, which is, you know, that square root of 3 is 1.732, you know, the value. So we talked about multiplication, addition, and subtraction of these numbers. Sometimes, you know, it's see, we can, as I said, we can write it. This one is to the power of 3, and x, suppose unknown number, x to the power of 2. You can write it this way: x 2 over 3, 2 divided by 3. You can write this way too. Now if you have something like this, multiplication now, x2 and then times the cubic root, this is cubic root of x to the power of 2, and this is x. What's going to be? So we can multiply this together, okay? We can say like this: x to the power of 3, and this is 3. This cancel out, the answer is going to be x. So we can write this in different forms. If the bases are the same, we could do this, but we cannot write like x to the power of 2, the cubic root of it, and multiply by y. We can do this one, you know, like this, but that's it. We cannot simplify. We cannot simplify anymore. No. So also, this is, I want to talk about this a little bit more. If we can write x to the power of 2 over 3 times to the x to the power of 1 over 3, see what we talked about. If the base is the same, we write the base and then we add these together, 2/3 plus 1/3. You know, see, remember that in talk about, showing graphically the number line is 0, 1, 2, 3. You know, this got to be equal. 2 minus 1 minus 2 minus 3. We said that a square root of 2 is 1.4. Okay, it's something in between here. A square root of 2, 1.4, 41, or 1.4 if one decimal place. So if it's minus, if it is minus a square root of 2, it's going to be minus 1.41. It's going to be somewhere here. Minus a square root of 2 minus is equal to minus 1.41. And also, you know, about these I was going to say, okay, let's come back to this. See, we said that if the bases are the same, we can add these together. 2/3 plus 1/3 is equal to x to the power, 2/3 plus 1/3. You know, he said that these bases are the same. The bases are the same. See, I'm saying the denominator is the same. We add the numerator together. It's going to be 3. We write the base here. We write the numerator here, and we add this denominator. It's going to be 1. So this is going to be x to the power of 1, which is x. We don't write this exponent. So how about if this one was x to the power minus 2 over 3? Okay. What does that mean? Let me x to the same thing, 1 over 3. It means x minus 2 over 3 plus 1 over 3, which is x to the power of minus. See, we write the denominator, and when we subtract this, it's going to be minus 1. Minus 2 plus 1 is going to be minus 1. See, and that is the way there's another way, you know, to to find out. See, let's talk about it. See what happened here. We wrote this one in an exponent form. We could write this one, and then we multiply. This is the multiplication. If you can, it's multiplication, we can do this. We can add this exponent together. But if this is not, is plus, what does it mean? You know, you can do this because you can do this when it's multiplication, but it's the addition. This one is plus this one. We just write. You know, this is the same original plus x. You know, you can write this. You can omit this exponent because if there is 1, we don't write it. So, in this multiplication, we can do this, but otherwise, we cannot do that. I mean, there are some things more complicated, a little bit more. If the exponents are the same, then base are different. You know, that could be another story. So, we are. That's enough for. That's enough for today. Or maybe let me talk about cubic root. No, the fourth root. This is 4, okay? And then we get an example like this. It's 16. We can write 16 as 2 to the power of 4, and 4 cancel out. It's going to be 2. If it's going to be 32, for example, we break it down. We say we got to find the perfect square of the number in this. 8 divided by 2 is 16, divided by 2 8, divided by 2. Actually, it is 2 to the power of 5 is equal to 32. So this is to the power of 5. Oh, this is if you have this one 4. Okay, we say 4. The index is 4. Fourth root of 32. So 32 is going to be 2, or we can write it 16 means 2 to the power of 4 times 2 to the power of 1. See, if we say this is the same as 2 to the power of 5, because if your base are the same, we add this together. This is going to be multiplication. So, oh, okay, I shouldn't raise that. So it's going to be 2 to the power of 4. We can write it this way: 2 to the power of 1. And 2 to the power of 4, it is 4. The index is 4. This is going to cancel.